Hello, good morning to all. Today I would like to share my assessment 1, 2, 3 and 4 and regarding which I had done so far related to it. Now coming to my first assessment here, in order to describe about the shear force and a bending moment diagram of a particular beam, which is I considered some different types of loads and different types of contact points and different types of reaction forces and different types of supports in this problem. Here I considered a beam with a hinge and a multi-loaded beam with having the roller and a fixed supports. And here in this assessment I describe about the shear force and bending moment diagrams and how I develop the shear force and bending moment diagrams for a multi-loaded beam. And coming to my solution, here we can observe that a beam with multi-loaded in the following diagram. So here at point A, I give a support in order to produce a reaction force at this particular location. And at B, I considered a hinge that which can transfer only axial and the shear forces but not the remaining all other forces. Hence, there is no bending moment at this particular hinge location. So, up to this location, only forces can be transferred but not the bending moment. And coming to the C and D, I considered these two particular locations having the roller supports. And I considered a uniformly loaded portion area from the starting point of the C and D, and at a particular location of the beam, I considered a point load which is acting at this location. And coming to my explanation of this solution determination regarding to the shear forces calculations as well as the bending moment calculations. So we need a free body diagram of this multi-loaded beam. So the following solution represents and having the free body diagram of this multi-loaded beam. Here I remove the supports which are having this question is having and place the respective reaction forces at that particular supports. And now in order to determine these forces, we need a free body diagram as well as a simple calculations regarding to the concurrent force calculations, as well as we are considering the forces in the sum of the total forces in the x direction as well as the sum of the forces in the y direction should be equal. Like that, those equations will help us a lot in order to find out the reactions at the particular supports, as well as we can find the shear forces once we determine the reaction forces at the supports mentioned. And by removing these supports, here at point A, we will have a two directional reaction forces will be there, and at hinge there will be no forces as we discussed before, and without the hinge the entire system will be statically indeterminate. So in order to make the system as a determinate, the hinge will provide and imposes an extra condition. Okay. And the rest of the two supports will be the rollers, and we will have only single directional reaction forces at the locations of the C and D for this. And now coming to the calculations of the reaction forces which can be shown in the adjacent figure. So here I considered sigma fx equal to 0. It means I consider the equilibrium condition in the x direction as well as the y direction, and taking the moments about the particular locations, we can determine all the reaction forces at once. So initially I considered the equilibrium condition in the x direction. Then we can determine that the reaction forces at particular A in the horizontal direction should be 0 because no other force is acting at this direction. In opposite direction to that also, so it should be 0. And considering about the bending moment about the hinge to be 0. Why? Because we already discussed that bending moment at the hinge should be 0 as there is no shear forces are acting at this particular point. So by considering this, we can take the moment so after considering this, we can find out the RAY, that is reaction force at the y direction at the A location. So again we can consider the at the end of the beam. So for example, taking the moment about the Z. So we can consider it is as 0. So then as we know that at both the ends the bending moment should be 0. Like that we can take it. So sigma MD should be 0 by applying the force values and into their perpendicular directions. Distances from that particular location should be equal. So considering the equilibrium condition at the D, we can determine the RCY. It means the reaction force at this location C. And by considering the equilibrium condition in the y direction, we can find the RDY. So here, by using these conditions, I can determine the reaction forces. And later, of course, in order to develop the shear force diagram for this, we can easily use these reaction forces as well as the whatever the imposed forces acting on that beam should be considered in order to find the shear force. So we can consider like up to A there will be no force acting, and as we discussed up to B there will be no force acting, and here up to C, in between B and C there will be a force that acting in the downward direction. So we can find out those value, and then we at the particular point C there will be a starting of uniformly loaded item from this portion to this portion. So using the based on the conditions we can determine the FC, and later using this we can determine that whatever the shear force acting at the point D. So after considering all these shear forces, we can determine the bending moments based on that. So up to this location, as we know that there is no shear force, there will be no bending force acting, and from that we can determine the bending moment using the formula. And from this point, as we know that a uniformly loaded beam is applicable, for a uniformly loaded beam, the bending moment diagram, it should be in the parabolic shape. Here, as we know that a point loaded force is acting, so it should be a linear one, and it should be it should be represented like declining. Why? Because the force is acting on the downward direction on this particular beam. So that's why it should impose a force in this direction, and resulting the beam should be bent like this. So that's why here the bending moment will be in the lower position, not in the upper position. So as slowly the uniformly loaded beam is considering, and at final moment of the D, the bending moment should be 0. So by calculating all these values for a uniformly loaded beam, the bending moment shape will be a parabola, and I represented that condition here. And this is about my first assessment. Coming to the second one, in the second assessment, I considered a truss with something loaded forces as shown in the figure, and I compared the theoretical calculations with the MD solid calculations. So here initially I considered that particular truss which is shown in the figure, and then I apply the different types of loads which are also shown in this figure, and then I find out the results of these and represented in this diagram. Then afterwards I consider the whatever the conditions I applied here in this software, I say the same conditions are applicable in the manual calculations too. Using the equilibrium conditions and the concurrent force diagrams and the free body diagrams, I find out the forces at the two different locations, which first one is RA and next one is AX. So what it means, I find out the reaction forces which are acting at the location A. Okay, then the results of the analytical calculations and the software calculations are different. Why? Because in the software some assumptions are made and the calculations are being carried upon those assumptions, and in another case we can simply say like that it will evaluate the accurate results when compared to analytical results. Why? Because when we doing some different types of techniques, like I used here the method of joint check. Maybe in the method of joint techniques there will be some assumptions during their derivations of the forces, of the derivation of this particular theory. So those assumptions made the realistic ones, those values won't be equal. So as we know that, so if we are considering some assumptions, then we can't simply match them to the realistic problems and realistic values. What happened exactly? So like that also, what I calculated using the method of joint values, those are not equal to the MD solids. Why? Because whatever the reaction forces, whatever the strengths are given by the software should be accurate, because of the so many considerations it will calculate, and it will develop a good solution based on all the realistic ones also. Okay, so that is a difference between the manual calculations and the software calculations here I can observe. And another one is I find out the diameter of the beam member, one beam member of this truss. So I assumed that factor of safety should be 2, and using the general calculations and general formula I find out the diameter, and I achieved the diameter of the member is 3094 mm. So as we know that factor of safety is related to strength and stress. So using the strength and stress values, these are developed by the software, I find out the diameter of the member. Coming to my assessment 3. Here in this assessment I discussed about the atomic structure of a hosting metal whenever an alloying element is added to it. So here, as we know that for example a metal or else a chemical is added to some other one, they should be react. So as we know everything, the chemical whatever the elements are there, almost all elements are reacted with one each other. Like that, whenever an alloying element is adding to the hosting metal, and we know another one too, what exactly is all metals are very reactive to any element, almost all metals. Some exceptional cases like argon gases, nothing but inert gases, and some rare elements. Also, if we consider those elements, okay, we can't find the compounds with those elements of the metals. But almost every metal is highly reactive, which are present in the periodic. Here, I have studied about the atomic structure, how it can changes, what exactly will happen whenever an element is added to that particular metal. I explain in this assessment 3. So I observed a few points that I can explain to you. Nothing but whenever an alloying a metal how it can be done is a combination of or a adding of another substance into it. So that is what exactly we learned in the chemical reactions, right? So, however, an alloying metal or element is adding. So, why? Because it is added means in order to improve its properties. So, a single element can't exhibit every property, but whenever an element is added to that one, it can exhibit like a combination of properties. That's the importance of adding of an alloying element. And one more thing, adding an alloying element can be performed by heating or melting using different heat treatment processes. So the process should be varied based upon the type of metal, based on the number of elements used, based on the size. So based on all these conditions, adding of alloying element is different. And whenever this process is being processed, there will be a change in properties of the host metal. And due to these combinations of the two different types of elements, we can observe there will be a change in the crystal structure because of the differences in the size of the atoms. So, whatever we exactly studied in the crystal lattice structures, types, bonds, so that is going to happen in this process. So, whenever the alloying element is added, that difference in the size of the atoms got reflect with whatever existing host metal is there, and that would create a stresses in between those two atoms in the metal lattice crystals. So, during the chemical reactions in between, or during the collisions, during the development of the stresses, so that is going to happen. There will be enhancement of properties for the combined material, whatever it is going to be prepared. And this combined element gives an extra strength when compared to the original elements. So, which gives us a very helpful to be in the application of the real-time practices. So, here I listed out a few of the examples and few of the advantages of the adding the alloying elements to a host metal. So, in general, I already discussed that alloying the elements, whatever added to the metal, can improve or can enhance the existing properties. Like that, I find out some information regarding to that. Whenever steels are added with alloying element, so those properties will improve that are related to the strength, wear and tear, and corrosion resistance. So that is why utensils, for example, we regularly use those ones. So those can be made up of the metals only. But we are daily washing those utensils. So if they are not corrosion resistant, it won't be helpful for us. So like that, in this case, alloying elements to the steel will help the increase of the corrosion resistance property, so that we can use in this specific application. And another one is the alloying elements will dissolve into host metal. Some alloying elements directly combined with other elements and can form a different material from that. So, for example, brass and copper, bronze and copper. So, like that, those can be mixtured and those can be used to making of the same utensils and some sculptures purpose. So, we can get coins like that. We can use particular that host metal. Also, some types of alloying elements should be added to the hosting metal in order to remove the properties or remove the impurities, as well as aesthetic sense. In case of aesthetic sense means giving a better aesthetic posture to the hosting element. So will looks like whatever the alloying element is added to it. Like that, for example, when we consider the ornaments. So in the ornaments, copper is also used or else we can see a mixture like a platinum and gold. So those will be combined, so which will be which will give a better aesthetic sense if we want to purchase, if we want to attract, like that. So those are some of the examples. So already I explained like the properties will be enhanced. So some of the adding of the traces of the elements will increase the following properties like hardness, hardenability, toughness, creep resistance, and those can sometimes at lower temperatures these can be improved, and sometimes at elevated temperatures these can be improved, like that, based on the type of environmental conditions, also based on the type of metal. The properties will change and the properties will be improved, and it can be different from one element to another. And coming to my assessment 4, here I can prepare like the how composites are manufactured. So nowadays composites are used in almost every application, and a very rapid study is going on the composite subject. So I considered this in order to gain some knowledge regarding to the how composites are manufactured, how I can achieve, and how I can implement the manufacturing of the composites in my future studies, like that. I would like to explain. So how I can explain how composites are manufactured, that I studied about this. Initially, in order to prepare the composite material, we need a different of the two different materials. So why? Because we need two different materials means the name itself describes the composites. So composites means a combination of 2 or 3 materials. Why? So in the previous assessment, I can explain like the composite can not composite, adding of the 2 or more elements or combined together can enhance the properties, existing properties. So here in the composite case also the same can be applied, and most of the composites can be made up of 2 only. Sometimes 3 or more can also be applicable, and the main things required for the composites are one is the matrix and second one is the reinforcement material. So in generally matrix materials are considered as the polymers like resins, polyester, epoxy, like these can be utilized as a matrix materials, and the second one is the reinforcement materials. Those can be included like the natural fibers like banana fiber, palm fiber, pineapple fiber. So those can be extracted from the trees and can be utilized in the making of the composites for enhancing the strength to the composite material. Also in some cases metal composites are there, we are using the metal powders. So or else like we can observe like a combination of 2 or 3 metal powders. So those can also be utilized in making of the composites. So making of the composites involve manual process as well as the automatic process also. So for the manual process, I studied like we required a mold design for that particular process, and using that mold, whatever the mixture we prepared by using the matrix and reinforced materials, those can be poured into the mold and can be applied the pressure for up to 24 to 48 hours of time. So which can ultimately prepare the composite materials of that particular mold shape. Also there will be a automatic process there. The automatic process can be used. For example, compression molding can be used in order to prepare the composites. So in that automatically whatever the pressure required we can apply using that machine. And why exactly the pressure is required is whenever we are mixing a liquid and with a solid, so there will be a formation of the air bubbles. So if the air bubbles are there, the strength of the composites will decrease. So in order to remove those air bubbles, the pressure will be applied to it. So and it becomes the reinforcement a good one. And I found out some benefits of the composite materials during this study. So whatever the I found some crucial applications of the composite materials I listed out here. So when compared to the metals and non-metals, the composite materials are very less in weight and can be utilized to even in the aerospace applications. So almost I already studied in some of the aerospace applications, spacecraft applications, some composite materials are utilized, and these composite materials will help in the reduction of the carbon dioxide emission, as because of they will take a less fuel consumption when compared to the metals. And we know that metals are corrosion resistant, but to some extent only. Whenever some rusting metal is added only, then will be it increases this corrosion resistant property, but usually the composites are always the corrosion resistance and have the more durability when compared to the others. So whatever the strength and performances of having the composite materials can make them to utilize in the wide variety of the applications. Also, some of the composites have a ultimate insulating and acoustic properties which can be utilized and which can be applicable even in our daily routine too. So almost numerous studies have been going on the composite materials, and this is one of the a rapid future study which we can applicable in even in the automobile industry, even in the refrigeration and air conditioning applications. We can apply these composite materials in almost every mechanical applications. And example having the highest strength to weight ratio of the composite fiber is the carbon fiber. And these are about my assessments. Thank you. If you're having any queries, you can please ask me. Thank you.